Professor Dr. N. Ganesh is working as a senior faculty, Department of Computer Science and Engineering, SRM University, City Campus, Vadapalani, Chennai. He has more than 12 years of undergraduate and postgraduate teaching experience, which includes 5 years of research experience. He has trained many corporate batches on technologies such as mainframes, Application Systems 400, SAP, ABAP. He has published 10 articles in both international and national journals. He has presented several papers in both national and international conferences. He has written 4 books which are prescribed in Anna University affiliated colleges, SRM University and Bharat University. His research interests are software engineering, data mining and cloud computing.
Welcome to UGC lecture series in computer science. We are going to see a series of lectures in the subject operating systems. This subject is for the students studying in their 5th semester of their BSc degree program. The subject operating system belongs to paper number 8. In today's lecture, we are going to see few topics from unit 4. There are several topics in unit 4, out of which we are going to see the topics such as allocation methods and free space management in files. So, the contents of this lecture are file allocation table, what is a file allocation table and how it is used, file allocation methods, different sets of file allocation method, in which we will be focusing on only one particular method, that is called indexed file allocation method. The third topic will be on free space management and the fourth topic will be on efficiency and performance that is being used in the free space management. Now, as a file allocation table, in our previous lectures we have seen various concepts on files, about the file system, about file handling and about the file operations that is being used in files, attributes of files, file control block and so on. And as well we have seen few topics on the disk, organization of disk and organization of directories in the disk and organization of files in the directory. So, these topics we have seen in our earlier sections. So, now in this lecture we will be concentrating more on the file allocation part. So, how a file is been allocated and what is a file allocation table. I suppose in one of my earlier lectures I have said about the different file systems that is being used in Windows. In Windows they use two different types of file system, one is called as a FAT file system, other one is called as an NTFS file system. Now we will see more details on the FAT file system, that is file allocated table, how a file is allocated, how it is stored and how the file is been retrieved from the directory, how the data has been retrieved from the files. So, those details we will be seeing in this today's lecture. Now, as a file allocation table, we will see an illustration, we will see a diagrammatic representation of how a file allocation table is. So, supposing if I want to call the file block number 217, then I make a directory entry, my file name is said to be test. So, this file name test, I need to find out where this file name test is been available in my hard disk. See, in my earlier lectures I said how to partition the hard disk, that is I asked you to partition of C drive, D drive, E drive and so on. So, the space available for C drive was consider somewhere around 200 GB and for D drive it is somewhere around 150 GB and for E drive it is somewhere around 100 GB, right. Now, all these drives are pretty free other than the C drive. In the C drive you have all the contents that are required for the required to boot the operating system, something like a program file, something like a Windows folder and so on, and the D drive and E drive consider it as literally free. Now, you have created a file, a Word document let it be, an MS Word document by name test. You have given the name of the file as test. You have placed that file in E colon, and now you wanted to take that file out using a search element. What you do is, how do you search? You click on the window button, you click on the start button on the keyboard, and then you go to find. Supposing we are going to use a Windows XP operating system, you go to find and then you type the keyword as start, because your file name is set to be the keyword as test, because the file name is set to be test in your case. You pretty well know that it has been kept in E drive, but supposing if you do not know that this particular file test has been available in E drive and you wanted it to search, and then you want to retrieve the result, the location of test. So in that case, when you type in test and when you press an enter key, what happens is that internally at the foreground you can find it as, on the screen you can find it as this test has been that is searching has been carried out in C colon and then in D drive and then in E drive till that. But what it does internally is that it takes the keyword test and then it goes to the directory entry. So from the directory entry it goes to the index location. So this is how it looks like in this figure. So you have a directory entry wherein the file name is set to be test and it goes to a location, and in the index you will be finding in place number 217. These are all set to be the different blocks, and these are all the numberings that has been given for different blocks. Something like these are all the identifiers for the different blocks. So it has been found that this file starts from the location 217th block. So it goes to the 217, wherein there it is giving one other location as it is available in 618 block. Why do you get the second location? Why the contents of the file is not been available in the same location itself? It is because of the contiguous memory allocation. I suppose we have seen about the contiguous memory allocation in one of our earliest lectures, wherein what is a contiguous memory allocation? You may be allocated a full set of memory, but it does not mean that all the file contents have to be stored only in one particular location. So it will be segregated, it will be split into several halves, and then each and every half will be stored on a contiguous way. Contiguous is on a random way within the allocated space. In one of my earlier lectures, I gave you an example with respect to keeping 10 children being seated in a sequential means from 1 to 10. If it is of continuous, we will be calling them as 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. If it is of contiguous, I may randomly pick the child as 1, 4, 7 and 10, and I may get the data. And based on that data, because I require data only from these 4 candidates rather than making it on a continuous means. So that is the major difference between continuous and contiguous. Here it is a contiguous allocation. So the test contents, my file name is set to be test, wherein let us consider I have contents of about somewhere around 120 pages. So it does not mean that all the contents have to be stored in only one particular location. So what happens is that the first 3 pages will get stored in a particular block size in a particular block, and the next 4 to 10th page will be stored in a different block, and from 11 to 25th page will be stored in a different block, so on. So what happens here is, my initial entry was, as according to the figure, it is name is set to be test, the start block is set to be 217, so it goes in the 217th place, wherein it could find certain details on this page, only some 2 or 3 pages of its contents. The remaining contents is available in a page called 618, in a block called 618. So it goes to the block called 618 and it again takes certain contents, but here again it has found that certain other contents are being made available in a block called 339. So from here, because this block contains two details, one is the pointer to the next location in the sense is where the contents of this particular file has been available other than this particular place, other one is the details available in this block. Now what happens here is it goes over here, then after taking certain pages it says that the remaining contents are available in block number 339. So it goes here and it goes to 339 wherein all the other contents have been taken from that location, and thus you get a retrieved result as the file test is being retrieved, and all the details when you click open the test on the search bar, when you click open the found item on the search bar, you could find all the details of the test folder, because it did not according to the user, you seem to have all the contents from page number 1 to page number 120 as said, but internally all the details will not be stored in a single place. It may or may not be stored in a single place. Like in our example, this contents was stored in 3 different locations. One was at 217th block, second one was at 618th block, third content was at 339th block, and all 3 contents put together completes this contents for the entire file test. So this is what a file allocation table is. Now let us see how an allocation method is being used and how it has been indexed, where to retrieve from the index value. So here when we see this, an indexed allocation, each file has its own index block or several blocks of pointers to its data block. Now let us see a logical view of it. This is said to be a data blocks wherein these are said to be the data blocks and this is said to be the index table. From here, that is, index is nothing but mapping from one location to other, we call it as an index. So when we could see an example, let us see an example with respect to an index allocation, how this file is been indexed and how the contents have been retrieved. Index is a location wherein it contains all the details in order to map the contents from one location to another. Right. Now we will see an example on a real time basis. So here it is. So here are the list of blocks available. This is said to be my disk, entire disk. This is said to be my cylinder. These are the blocks that are available. I am going to find a file by name Jeep. My name of the file is said to be Jeep, and I need to find whether this file is available. If at all it is available, I need to check from where it is available. Now what I do is, when I give a check, it does not, in our earlier case what we did, file allocation table, we went to a location and from that location it redirected us to a different location. From 217 it redirected to a different location called 618, and from 618 again it redirected to a different location called 339. Now what we are doing is, we are having an indexed value, index table. So what this index table does, this file Jeep, when I call this Jeep, it goes to it searches on the index location, and in the index location it finds a block by number 19 and it goes to 19. In 19, these are the details that has been stored. What are these details? Details are 9, 16, 1, 10, 25 and so on. So what happens here is, when it goes to 19, 19th block is said to be my indexed block. So when it goes to 19, it goes to, it searches, that is, these file locations are being put in, stored in block number 1, block number 10, block number 9, block number 16, block number 25, and other -1 is nothing but we do not have sufficient set of information, so it has been given as -1. So when we have all these things, the data are retrieved from block number 1, block number 9, block number 10, block number 16 and block number 26, and it goes into this 19, and then our data has been retrieved from this file. So, this is an example for an indexed file allocation. So, with this we will have a short break and we will resume after the break. Welcome back. We were discussing about file allocation table, and that too before the break we were exclusively discussing on how a file has been allocated using an indexed allocation. So, I gave you we were seeing a diagrammatic representation of how a file has been indexed and how the data are been retrieved. I gave you an example with respect to retrieving a file by its name called Jeep. The name of the file is to be Jeep. So, now let us see the advantages of using an indexed allocation, or let us see step by step what is the usage of using an indexed file allocation. So, here the first advantage is it requires an index table. The second one is it does a random access. Third, dynamic access without external fragmentation, but have overhead of index block. Because what do you mean by fragmentation? I will explain you shortly. Fourth, mapping from logical to physical in a file of maximum size of 256 kilobytes and block size of 512 bytes. So, we need only one block of index table. So, this is said to be my block wherein Q and R are said to be, Q is said to be the displacement to the index table, R is said to be the displacement into the block. So, now what is fragmentation? I suppose when you are working with Windows operating system exclusively with respect to Windows XP or so, you would have seen disk defragmenter. What do you mean by defragmenter? Have you ever given disk defragmentation? Defragmentation is one which organizes, which arranges the disk in a particular fashion so that the retrieval is faster. When your computer is pretty new, when you have installed an operating system pretty new, then that means at that juncture your system would have been defragmented. All the mappings will be, it will be in a proper way. After a certain period, what happens here is we will be copying, we will be pasting, we will be deleting, we will be giving a confirm delete, we will be deleting it and it will be kept in a recycle bin. Supposing it is going to be kept in a recycle bin, at one particular point of time what we do is we will be right clicking it and we will be saying it as restore to the original point. So, you have deleted from D drive. Say for example, you had a file called by name Jeep and you had deleted it, pressed the delete button. So, it goes to the recycle bin. Do you mean to say that it got deleted completely from D drive? No, not at all. What happens is that is according to the user it got deleted from D drive, but according to the system it goes and stores in a place called recycle bin, which is part of C drive, which is part of an operating system, and from that location from C drive what happens is that is supposing if I want to restore it, then internally a pointer is being mapped from this D drive at the deleted location to the point of the C drive in the recycle bin. Supposing we are going to restore it back, then from recycle bin it goes and sits back to the original location D drive. So, I suppose it will be very clear to you people, because this is a real time example wherein you could find how the deletion and again re-entry of the particular file takes place, and this is a very good example to show a pointer to have an index from one location to the other and from other location to this the original point. So, the other details are, as far as the performance wise is concerned, this is said to be the best method that depends on file access type. It is contiguous allocation is said to be best for sequential access and for random access. It is linked good for sequential but not for random access. So, declare the access type at creation, select either contiguous or linked. There are two types of allocation, one is to be contiguous, other one is to be a linked allocation, which we have seen in our earlier lectures. So, as far as contiguous is concerned, allocating in a random basis. Linked is concerned, you have a link between one block to the other block. So, if a link gets cut, then you cannot retrieve, you can retrieve only half the set of data and remaining half cannot be retrieved. Now, let us move on to the next topic, that is the free space management. What is a free space management? Free space management is fine. You have certain files to be stored. After storing certain files, you require certain free space for managing those files that has been stored. You may move from this location to that location, you may delete a file, you may add contents to the file, you may increase the size of the file, you may decrease the size of the file by deleting certain contents from the file. So, all these things have to be managed. So, in order to manage all these things, you require certain free space. So, that is called as a free space management. Effectively managing the files for faster retrieval, faster recovery, we require a free space. So, managing free space effectively, we call it as a free space management. So, in this case of free space management, it uses a bit vector. What is a bit vector? A bit vector is otherwise called as a bit map. What is a bit? What is the difference between bit and a byte? As you might be knowing, a bit is a binary digit, and what is a byte? Byte is 8 bits, you call it as 1 byte. What is a kilobyte? 1024 bytes, you call it as 1 kilobyte. As in real time example, it is not like 1000 grams is not 1 kilogram, that is in grams and kilogram. 1000 gram is 1 kilogram, whereas in computers 1024 bytes, you call it as 1 kilobyte, and 1 bit is equal to 8 bits is equal to 1 byte, and 4 bits is equal to 1 nibble. I give you these terminologies because in our forthcoming slide we are going to use all these terminologies for making certain calculations. So, now this bit vector, this bit vector is otherwise called as a bit map, wherein here we have 1 block of I is said to be free and 0 block of I is said to be occupied. So, this is how it has been used. In the case of contiguous, it will be using 0 and 2, or in 4 the files may be copied, but the remaining location may be free. So, in order to calculate this, we will be seeing a formula for calculating the block numbers in terms of free space management. So, number of bits per word into number of 0 value words plus offset of first 1 bit. What do you mean by 0 valued words? 0 valued words is, supposing we are going to have certain spaces. He is a good boy. He, one space, is space, a space, good space, boy. So, to store this, it gets converted into the binary value, because in computer anything and everything it can understand only in terms of a machine language. Machine language is nothing but zeros and ones. So, this space will also be given a value, and that is said to be a 0 valued words, wherein you do not have any specific values for it. So, as far as this block number calculation is concerned, the formula is number of bits per word into number of 0 value words plus offset of first 1 bit. So, CPUs have instruction to return offset within word of first 1 bit. So, this is how we calculate a block for a block, we create a block for a free space management. Now, if the bitmap requires an extra space, let us see a real time example of how a bitmap requires an extra space. So, if the block size is equal to 4 KB, which means that it is of 2 power 12 bytes, disk size equal to 2 power 40 bytes, that is 1 terabyte. So how much of free space is required? So free space equal to disk space divided by block space, disk size divided by block size, which is 2 power 40 divided by 2 power 12, which is equal to 2 power 28 bits or 256 MB. If there is a cluster of 4 blocks, then we require 64 MB of memory. So it is easier to execute or get contiguous files than the linked files. Now let us see a real time diagrammatic representation of a linked free space list on disk. Here the first two in this, the free space list head we are supposed to denote. So these the blocked numbers are said to be literally free, wherein in the other open numbers, let us consider there are certain values being loaded. So these are the free spaces. So for the first block you have a pointer, you have a location, and this points to the next block. So this first block denotes that this is said to be free. From here, due to the link available, it goes from 2 to 3, 3 to 4, 4 to 5, 5 to 8, 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 13, 13 to 17, 17 to 18, 18 to 25, 25 to 26 and 26 to 27, and then it ends. So these are the free space of how it gets calculated. Now we will see the free space calculation based on two different aspects. One is by either by grouping, other one is by counting. What is grouping? Grouping is modify the linked list to store address of next n minus 1 free blocks in the first free block plus a pointer to the next block that contains free block pointers. Next is counting. Counting is space is frequently contiguously used and freed with contiguous allocation, extents or clustering. It keeps the address of first free block and count of following free block. How many number of free blocks over here? So these are said to be the free blocks. It keeps track of only of the first free block. Other free blocks have been linked. So when you are going to track this free block, we can easily traverse to all these blocks. So that is called counting. Whereas grouping, in the case, it is going to have free blocks in first free block plus a pointer to the next block that contains free block pointer. So counting is far better when compared to grouping. So these are the two ways of managing the free space. And then in our ZFS, in our Solaris operating system, we use a free space management called as space maps. So space maps, they use a concept called metaslabs. Metaslab is, it divides the hard disk, gets divided into several regions of free spaces. So that is how it has been worked out in a Solaris operating system, which uses ZFS file system, that is zettabyte file system. That is called as usage of zettabyte file system is used in Solaris operating system, and it is called as space maps. So wherein they use a metadata IO on very large file systems, and this it divides the device space into metaslab units and manages the metaslabs. So this is how it is used in Solaris. Now how it is efficient, and efficiently how the efficiency is dependent. So the efficiency is dependent on the following factors. One is disk allocation and directory algorithm. Second is types of data kept in files directory entry. Third is pre-allocation or as needed allocation of metadata structures. Fourth is fixed size or varying size data structure. So this is how the efficiency is managed. And the other management efficiency management is of the buffer cache. Buffer cache is a buffer memory, and then synchronous writing and asynchronous writing. Synchronous writing is sometimes requested by applications or needed by operating system. Asynchronous writes are more common, which is bufferable and it is faster. Now let us summarize whatever we have seen in today's lecture. So we have learnt about the file allocation table. We have seen the file allocation method, one file allocation method, that is an indexed file allocation method. We have discussed about the free space management and the efficiency and performance in using the free space management. Now let us see what are the possible questions that could arise from today's lecture. So question number 1, what is a indexed file allocation method? What is a bit vector? How are block numbers calculated in free space management? Where are space maps used? How is efficiency dependent on free space management? With this, we come to the end of today's lecture. We will be seeing more topics in our forthcoming lectures.